Okay, on this video, we're going to discuss remainder theorem, okay, and some problems related to remainder theorem. Okay, so when we say remainder theorem, it simply tells us how to find the remainder. Okay, how to find the remainder without using long division, without using synthetic division. Okay, so what does it tell us? That if we have a polynomial, let's say our polynomial is p of x. If we're going to divide that polynomial with um, a linear divisor, okay, let's take note of linear divisor. Okay, let us say the linear divisor is x minus c, where c is any real number. Okay, this tells us that our remainder, okay, will just be p of c, and that c is just actually that one. Okay, so meaning we're just going to evaluate the polynomial when x is equal to c. Okay, when x is equal to c. Okay, so then the result is actually the remainder. Okay, so example, let's say number one. Find r r when let us say 3x cubed minus x 2x plus 5 is divided by x minus 2. Okay, so the first thing is, let's set this into 0. So it tells us that our c is just 2. Okay, so this will become x minus 2 equals 0, then therefore x is 2. Okay, so we're just simply going to substitute this x equals 2 in this, then the result is actually the remainder. For formality, it tells us that uh, p of 2 is actually our remainder. Okay, p of 2 is actually our remainder. So when we do that, so p of 2 will become um, 3 3x cubed minus 2x plus 5, replacing all x with positive 2. So we have 2, then 2. Okay, for this you'll have uh, 8 24. Okay, 8 24 minus 4 plus 5. So basically this is just 25. Okay, therefore 25 is our remainder. Okay, 25 is our remainder. It tells us that if we're going to divide this, okay, using divide this by x minus 2, the result, the remainder is 25 without long division, without synthetic division. But let's find the remainder using synthetic division, so that we'll see if it really matches our r equals 25. So remember, in synthetic division, we'll just get positive 2 for that. Then let's take the coefficient of our polynomial, which is that becomes 3, 0, because there is a missing term, negative 2, then 5. Okay, then we will have 3, this becomes 6, then 6 becomes 2 times 6 becomes 12, negative 2 plus 12 becomes 10, 2 times 10 becomes 20, 5 plus 20 becomes 25. Okay, so which is this one. Okay, so you can solve you can find the remainder without using synthetic division. Okay, so number 2, suppose we have find r. Let r denotes the remainder. Okay, find r when 2x uh, cube minus plus 1 is divided by, let us say, 2x minus, let us say, plus 1. Okay. Set this into 0, you'll get 2x plus 1 equals 0, you'll get x equals negative 1 half. So, meaning our remainder is just p of negative 1 half, which is actually our remainder. Okay, substituting negative 1 half to x, you'll get 2 times negative 1 half cubed minus 3 times negative 1 half plus 1. And you'll get negative 1/8, positive 3 over 2 plus 1. And you'll have this one becomes negative 1/4 plus 2 and 1 half. Therefore, 2 and 1/4. Or simply, this is 9 over 4. Okay. 9 over 4. Therefore, the remainder, we're going to divide 2x cubed minus 3x plus 1 by 2x plus 1. The remainder is 9 over 4. Okay. So that's all for remainder. Now let's go to related problems about remainder theorem. So let's say that's number 2. Okay. Suppose we have the when x cubed minus 2x squared plus px minus 1 is divided by x minus 2, the remainder is 3. Find the value of p. Okay, so the problem tells us that what must be the value of p here, such that when we divide x minus 2, the resulting remainder is positive 3. Okay, so again, the same principle. We know that this becomes x equals 2. Okay, that becomes x equals 2. We know that p of 2, okay, meaning this is actually a remainder, p of 2, which is equals to the remainder, which is 3. Okay, so it's the same principle a while ago. Okay, so if we're going to extend this, you'll have substitute this 2 in this one, so we'll have simply x cubed, correct, then minus 2x squared plus p times x minus 1, and the result is just 3. Okay, so x cubed becomes 2 cubed because we have x equals 2. 2x squared becomes 2 times 2 squared, then px becomes 2p. Okay, so here it becomes 8 minus, it becomes 8, then plus 2p minus 1 equals 3. So we'll have 2p equals 4, because it becomes 0. Therefore, p is just 2. So that's how simple it is. Okay, p must be 2. The value of p is 2, such that we're going to divide this polynomial by x minus 2 with p equals 2. The remainder becomes 3. Okay, the remainder becomes 3. Okay. Next problem is a little bit higher than this. Let's say this is number 4 problem. So we have here, when x raised to 4 minus px cubed minus 2x squared plus qx minus 1 and x cubed minus px squared plus qx minus 5 are each of those polynomials are divided by x minus 2, the remainders obtained are negative 3 and 1 respectively. The goal is find the value of p and of q. So here we have two unknowns. Remember, when you have two unknowns in a problem, it is most likely that you're going to form two equations involving those two unknowns, so that you'll get that by elimination, by substitution, by comparison, or by whatever method you know. Okay, but first let us form our equation. Okay, let us form our equations. But let's establish first the information. We know that if we're going to have if we're going to have if we're going to divide this by this one, okay, the remainder is 3. So what does it tell us is that the same concept a while ago will have, this becomes x equals 2. We have p of 2 equals negative 3. Okay, so let us say this is our p of x, and this is our, let us say, q of x for this one. Okay. So cube of x not a quotient, but let us say that's polynomial. So p of 2, substituting 2 in the first polynomial, that's negative 3. The remainder becomes negative 3. So what does it tell us? It will be, let me just move the equal sign, even if it's not in column. So we'll have x raised to 4, okay, x raised to 4 minus px raised to 3 minus 2x squared plus q times x minus 1. Okay, so if we're going to substitute 2 here, okay, the result is just negative 3. Okay, so 2, 2, 2, then 2. Okay, so you'll have 16 minus 8p, okay, then minus 8, then plus 2q minus 1 equals negative 3. Sorry for the columns, even if they are not in equal sign, they are not in columns. We have here, it's going to be 8p plus 2q, then we have 16 minus 8 is 8, minus 1 is 7. Okay, 7 and negative 3 gives us negative 10. Okay. Of course, we can simplify the expression further by 4p, dividing both, all terms by 2. We have plus q equals negative 5. So this is our first equation. Okay, it's our first equation. That's first. Okay. So our second equation is just, if we're going to divide q of x by x minus 2, the result is 1. The remainder is 1. Okay, so it simply tells us that q of 2 is just 1. Okay, q of 2 is just 1. So we can, the same, we're going to use this polynomial. We'll have x cubed minus px squared plus q minus 5. The result is just 1. Okay, replacing all x with 2. Okay, so we will have 8 minus 4p, okay, then plus 2q minus 5 equals 1. Obviously, we'll have negative 4p plus 2q equals 8, and negative 5 becomes positive 3. With 1, we have negative 2. Okay? So this is our equation 2. Okay. We can furtherly simplify our equation. This becomes uh, 2p minus q, and dividing by negative 2, all terms equals 1. Okay, negative 2, positive 2p, negative 2, negative q, negative 2, positive 1. This is our equation 2. So, as you can see, we are able to form two equations using these two unknowns, which are the p and q. Now, since we have two equations, let's solve this using the famous, the elimination or the substitution. But I think elimination will do. Okay, we have 4p plus q equals negative 5. Then we have also 2p minus q equals positive 1. So this becomes 0. This becomes 0 here by addition. So let's add this equations. Okay, let's add them. So this becomes 6p, and the plus q and negative q becomes 0. Then we have negative 5 and 1, add them is, we have 4, negative 4. Then p is just negative 2/3. P is just negative 2/3. Okay, let's check. I think that's it. So we have p equals 2/3, and let's solve our q, the value of q. So we can use this equation because it's much easier. We have p is 2/3, so that's going to be negative 2/3 minus q equals 1. We'll have negative 4/3 minus q equals 1. Therefore, you have q is just negative 4/3 minus 1. You'll have negative 7/3 equals q. I think that's the value of q. So I think that's it. Okay. So since there are two unknowns in the problem, you have to form two equations using those two unknowns. Solve them using elimination, whatever. Elimination, substitution, comparison, whatever methods in solving simultaneous equations.